3 Linux servers, 3 Linux computers have been hacked. Let's analyze them in this CTF, in this challenge. We'll start the attack box to be able to analyze them and then deploy the first virtual machine. So we click, let's connect to the first Linux server, to the first Linux computer. So to do so, we can use a tool called SSH. It's a terminal tool, a command line tool. And then we connect to the address, which will be different once you try this challenge, and with those username and password. So we can say connect to the address, so SSH space username at the address, which is going to be different when you start it. And then type the passwords, which is listed right here. So we can actually copy it, or you can type it manually. And once you're logged in, you should see this. So thread at Acme Web with some message from Ubuntu. So click check and let's go to the next task. So first task is to navigate to this folder. We can easily navigate to that folder. If you check pwd, you'll see we're in the folder home thread. So that's pwd, we're in home thread. And we need to go to var log Apache 2. So we set to cd, change directory, /var/log/Apache 2. If we check pwd, you'll see we are now in the folder var log Apache 2, which is also indicated here. So with the command cd, you can change the directory, and we are now in the other directory. Then they ask how many tools made different requests to the server. Now the server keeps logs, these are text files, of everything that happens to it. These log files are stored in var log, and in this case they have a web server called Apache 2. If we check the files and folders in this directory, you'll see we have an access log file. So in the access log file, anytime someone does something to the website, it's going to be recorded. So they ask us what kind of commands did they send. Now if I take a look at the access log file like this with the cut command, it's going to output the contents of access.log. And I press enter, you'll see they did a lot of different commands to this computer. You'll see a lot of get commands here. You see get appear a lot of times. Then you'll see post appear here. And also the head command. So there's different things that you can see directly from this log. But we also see a blurb of information. So we can actually filter this information using a tool called AWK. So we can say AWK print and then which of these items. So maybe the 6th item might be the get commands. So if we do the first one, we should get the internet address. And you'll see it's not, so this first one. And you'll see the first one is the internet address. Now, we don't need the first item, but probably the 6th. So let's try that. It's a wild guess, so 1 and so on. This might be 6. And you'll see that is 6. So a lot of times they did a get command. And we see some others here as well. Post, options, different commands that have been sent to this computer. Now, they said about how many different tools made these requests. So we don't actually need the commands, but we need the tools. So let's take a look again at this access log. And we can see the tools names listed here at the end. So that must be a higher number in the line. So that is, if this is 6, then this might be 8, 9, let's try. So 9, it's not 9. We can simply try different numbers. And now we see tool names, right? Mozilla, curl, these are actually computer software. So we take the 12th item from that list. So if we have this list, you'll see the first item and then second, third, and so on. We know that this is the 6th. And then all the way at the end, there is either a dash or a tool name like Mozilla 5.0, Windows, different tools. We see Mozilla 5 iPhone, so different tools. And we can filter that with this command to only have those tool names. Now, we do see a lot of duplicates. So what we can do is reduce this list and only show the unique ones. So that kind of works. We see some of them, but still not completely. Let's say we sort this. And then try the unique again. And now we only see the unique ones. Now, this is a bit of a trick question because they ask how many different tools made requests to the server. So Mozilla is just a standard web browser like Firefox, like Chrome, It's just a standard program, so they don't consider that a tool. Then you have Apache, which is the actual program on the server, on the Linux computer, that gives you the websites. So you can ignore that as well. So they have two tools, Deerbuster and curl. These are two tools that hackers sometimes use to get more information from the server. In Deerbuster, it tries to scan for different folders on the server that might be hidden, and curl downloads something from the server. So two tools are used here. This is a web browser, the Mozilla, and Apache is the program that gives you the websites. So we can fill in 2. Then they say name a path requested by NMAP. So what we can do, we could simply print out the access log and perhaps search for NMAP. You grab NMAP and you'll see it lists all the times NMAP has been used. NMAP is another tool hackers often use. So the question here is name a path requested by NMAP. So a path is any link here. So we have this /link. That's probably not the one they want. We have evox/about, robots.txt. So there are different ones. Now, this could be any ones, but probably they want a directory. We have this nmap lower check, some long one. Let's try this long one just because it really stands out. Let's copy that. And that seems to be the one. It really stood out because of the lint. So we got it simply by filtering the log file and searching for the word nmap. With the grep command, you can filter any text file. So that's pipe grep, and then the word you're looking for, in this case nmap. And then it's only going to return the lines in the file containing the word nmap. Okay, let's go on to the second one, the web analysis. So apparently there's a page that allows users to upload files. Now we could search inside the folder var apache 2, so in this folder, which only contains log files, right? So only text files of what happened to the server. Or we could try checking the folder with the web files ourselves. We could do a quick look at either one. So let's say take a look at this access log and maybe search for upload. In this case, it doesn't return anything, so they ask which page allows uploading. So we could search for .php, and there's simply a lot of different files. So what we could do, instead of browsing this endless log file, we could go to the folder var www.html. That is where any website is located on a Linux computer. List files and folders. And we see some HTML files, contact.php, and uploads. Now, PHP is a script file. It allows running program code called PHP, the programming language. So we could take a look at this contact.php to see what is inside it. So I do cut contact.php, and here it says something about uploaded file, and some other things. So it looks like this file is for uploading. If we simply type contact.php and check, you'll see it is that file. Now, let's go back to this access log file, because they say what IP uploaded files to the server. So they might have used this contact.php, it's this file we just found, for uploading. So let's take a look at the other folder, cd var apache 2. We're in the Apache 2 folder now, the log folder. List files and folders, we have access.log. We could search access.log, and now that we know there is contact.php, we can simply filter on that with grep. So we type grep and give me any line in that access log that contains the word contact.php. So we get a whole bunch of contact.php files, and also we see some internet addresses. So here they see different get commands. So it might be any of these IP addresses. And what we can do is simply try it out. So let's say we try the last one. So we say 192.168.56.24 and see that is correct. Now they ask who left an exposed security notice on the server. So we might actually discover that using the access log. So that file, maybe access log, we could possibly find that security notice. So what we can do is simply output it, but this would be too much data to filter through. You see endless lines of text. So what we can do is filter out any 404 error. So any line that doesn't contain 404, that would be the first step, and ignore all the 404 pages. And we could search for Deerbuster. So the Deerbuster tool and simply discovers any files and folders. It's a tool used by hackers, and in this case Deerbuster has been used on this server. So let's press enter and see what we find. And you'll need many different things here, head commands, get commands. So we also want to filter for get commands. Get commands is when you get something from a web page. You say rep get, press enter, and you'll see we find different things here. So we get all kind of files and folders here. Now in this list somewhere we might find this security notice. So in this case we see many different get commands. So there's folders inside folders on the computer. You'll see resources, developments, 2021, many different folders inside another, but no security notice yet. So what we could do, let's say we filter this on Deerbuster again, and might take a bit of fiddling with these commands. Let's say we only search filter for Deerbuster, and let's get a bigger screen because it's quite hard to read like this. So static error, administrator HTML, certificates, CD-ROM. You see all kind of files are on this server. Now what we look for is of course a security notice. So that could be in different format. It could be HTML, could be TXT, could be Markdown. And there are many different possible formats in which a security notice might be stored. Now we could filter. For example, we could say only TXT files. In this case there's nothing, only HTML. So many different HTML files, but we already checked these. We could check for Markdown files, MD. And here we go. We have resources, developments, 2021, docs, security.md. So let's open that file. We go to var www.html. And then in here, we should have resources, developments, 2021, docs, security. So let's try to output a file, resources, developments. Notice that I'm just going to open the same thing, so might as well copy it and then paste it in. And then it tells us that this file doesn't exist. So it might be a decoy, but let's take a look. Let's go into resources, developments, 2021, docs. And then we see the security.md. Now let's output it with the cat command. And you'll see blah, blah, blah. And the user who left it is Fred. So let's try that. Fred left the security notice. And there we go. We completed this web analysis task. Let's go to the next task. They say, it looks like our attacker got into the computer using remote file inclusion, so a type of vulnerability. It's best to look around the system. So they ask, look around the system to find out how did the hacker get in, what command option did the attacker use to establish a backdoor. So they tell us investigate different things. So let's take a look. Let's go to the home folder. And the first thing I always check out of habit is this bashrc file. You'll see that's a hidden file, and on the latest computer, when a user logs in, they're gonna run the commands inside the hidden file bashrc. So if I do ls-al, it's gonna show you the hidden files. You see here it looks like there's only this folder. But when I add this -al, it shows hidden files, and you'll see there's a bunch of stuff. One of them is the bashrc. Now that is one way hackers keep persistence, keep having access into the computer, because it runs commands anytime you log in. So what they typically do is that once you log in, it's gonna connect to their computer again and give them access into your computer. So it's like a backdoors can be configured inside bashrc, because anytime a user logs in, a command is run, or whichever commands are added to it. So this is one of the ways they keep persistence. They keep having access into the computer. Let's check this file and see if there's anything inside it. So we cut the .bashrc file. Notice the dot here that makes the file hidden in Linux. And in this case, we don't see anything special in here. Typically, in these TryHackMe rooms, something is added to the end if there is something. Now, every user has its own bashrc file. Now, we are the user root. We are the user thread, but there are other users on this computer, or there might be. So if we check /home, you'll see there's only thread here, but there's always an administrator, always a root user. So let's do the command sudo su, and then we need to type the passwords, which you can find here on top, right? So in the deploy VM, you'll have the password. And now let's take a look in the folder, not home thread, but in the user root, the administrator. So we go cd root, files and folders. We list the files and folders with this command, including the hidden ones. And then we check the bash history, so the bashrc, sorry. And in this case, there seems to be nothing inside the bashrc file either. So it might be something somewhere else, right? It might be one of the other techniques that were used. We also have this bash history. We put check just for fun of it. So let's see the bash history file, nothing inside it. Or for the great user, bash history, nothing inside it either. So we might need one of these other ways they could get in. It could be a cron job. So a cron job is simply a task that is scheduled. You can have one or more cron jobs on a Linux computer, and they will automatically execute at a certain time. So to list them, we can say cut etc cron task. And here we see a command from user root2. And then we see, which obviously that is not a real user. Root is the administrator, and there is no administrator 2 on the Linux system, neither on Windows or Mac. Root 2 is not an existing user. So this is in itself very suspicious. And then we have this sh-i and this command with an internet address and a port in it. So this doesn't look good. So it might be they're simply looking for this. Let's try. And there we go. We found this first persistence mechanism, a way of hackers to keep into the system. So what happens here is a cron job. You see we listed the cron task, which is scheduled tasks. And then the user root2 has a task which connects to this address and this port. And what this command does is a reverse shell. So it gives them direct terminal access into this Linux computer. Okay, that's the trick they are doing here with this line. And it is suspicious in itself because we have this root2 and because there's an internet address in here. So you shouldn't be finding internet addresses in your scheduled task. That might be suspicious. So next, they say it looks like the command from the previous task was set up under the user root2. The account doesn't make any sense, as there should be only one root account. How did they get there? So there's a couple of locations where account information is stored. It gives two files, etc passwords and etc shadow. Now, typically Linux passwords, they are stored in etc shadow. In the past, they used etc password for it. But they don't do that anymore. Now the passwords get stored in etc shadow. So if you find any passwords in etc passwords, that means an old encryption system was used. But let's take a look at these two files and see if we can find the passwords of the second root account. So if we take a look at the file etc passwords, we can see all the users and extra information. So you'll see different users here. For example, every line is a user. So we have user threads, which has the home folder home threads and is using the program binbash to interact with Linux. Then we have this user, root2, with this passwords. Now this is a hash password, this is not actually readable. And then they have the folder roots and binbash. So let's try to crack this password. So this password is stored in a hashed format. It's a way to store passwords that are not human readable. But these hashes, they can be cracked using a tool called John. So what we can do is copy this hash. Then let's say we open a new terminal because we don't have the hacking tools on this Linux server. So let's say we open a new terminal, open a tab. Now notice we are in the attack box now. Root adds this address here. That's our attack box. That's our hacking computer. We are not inside this Linux computer, this Linux server on threaded Acme web. We are inside our own. So if we type the tool name John, which is a hash cracking tool, you'll see we get some output. If we do the same thing on this computer, you'll see there is no John. This is a live Linux server. So we copied this hash. So right-click copy. Then we'll save the hash. So we can do this in any text editor. Now for simplicity, let's do it with nano. And we call it hash.txt. Paste it in, Ctrl-O to save, Enter, Ctrl-X. And now let's crack that Linux password. We type John, followed by hash.txt, and press Enter. And then we wait. It's gonna crack the Linux password. Here we go. The tool John, it cracked the hash. So with John hash.txt, which contains that hash from etc password. So this hash, this password hash, we save it into hash.txt. Then we run John with the hash.txt and it outputs the password Mr. Cake. So John is a password cracker. It can convert hashes into the original password. And Linux systems store passwords in hashes for security reasons. But that doesn't mean that they cannot be cracked. Using a tool called John, you can crack the password hashes. So in this case, we need the Mr. Cake password. And then the first Linux server is done. But oh no, the second Linux server got hacked again. So let's investigate that one. So we'll close this terminal, this old machine. And then we'll start the second machine, boot up, and then we need to connect to it. So we can close this one and say exit. We can exit, and you can clear the screen here and then simply wait for the second machine to start. The second machine has started. We now have the address visible. Let's connect to it. So we say SSH. And then copy the username is Fred again. There we go, Fred. The target address, copy it. Let's connect the target machine. We type yes, enter. And then we copy the passwords in that little clipboard. And then we paste it here, press enter. And then we should be connected to the target machine. So there we go. We see Fred at Acme Web. That means we are now connected to the second Linux computer, the second Linux server. So let's go to the next task where we have Apache log analysis 2. So we go again to the folder var log Apache 2. That's where the log files of Apache are stored. Then they say name one of the non-standard HTTP requests. So if we take a look at the access log file, we have many different requests. We see GET requests, POST requests, and we might find some others here. So instead of scrolling through this endless list, what we can do is filter it with AWK. You can say AWK and then print, I believe it was the 6th value, these commands. So let's try. And you see we get the unique commands, the HTTP commands, and it's saying we filter by the unique ones. So we see there's only a bunch of HTTP commands. And in this case, get and post are normal ones. When you do a GET request, you get something from the web server, from the Linux computer that runs the web server. It gives you the website or an image. When you post something, you upload it. But we have a weird one here, GXWR, which isn't even an English word. So probably that's the non-standard HTTP request. Right, it's not even an English word, it's GXWR. Then they want to know at what time was an NMAP scan performed. Now, if you read this whole text, at some points they say NMAP will send HTTP requests with a random non-standard method. So at some point they're going to do some random commands when performing an enumeration task. So NMAP, it lets you scan computers. So what we can do is simply search for this again. So we simply do the cuts with the outputs, and then we do grep GXWR, and you see it's gonna bully us. So what I'm gonna do is simply open this text file in Vim, and then search for GXWR. So in Vim, access.log. So it might take a second, then I do escape /GXWR, and then we find a timestamp here, 2021, and so on, and the time 13/30/15. So 30/30/15. Now I quit Vim, you holding Shift key and ZQ, and we have now exited Vim. Okay, so it seems this they have another way they keep into the system, persistence mechanism 2, and they say the hacker has been a little bit smarter this time around. If any backdoor exists, it's likely to be more subtle. SSH keys are another way. I mean, they randomly say here SSH keys, right? Are another excellent way of maintaining access. So sounds kind of like a hint. Might be worth looking for additions to the authorized _keys file. So we could say take a look in threads folder. And inside threads folder, you see there is no .ssh folder. So normally when you use SSH, when you remotely connect to someone, there is an SSH folder. For example, if I open a new terminal window here, we're inside the attack box, inside the hacker computer. If I do ls-al, you'll see there's a .ssh folder. If I enter that, you'll see there's this authorized key folder. So that's always in .ssh, always that hidden folder, but thread doesn't have it. So it must be another user. It might be the root user. Let's take a look. We do sudo su to become root. We type the password again. So that's the password that's displayed here. That's this password. So we go back to the persistence mechanism. We go to root folder, cd /root. So we are now in root. List files and folders. We have the .ssh folder. We can enter it. Then we can take a look at this file, cut authorized keys. And then they ask what username and hostname combination can be found in one of the authorized key files. So obviously this is Kali at Kali. Kali Linux is a Linux system often used for hacking. So right click copy. And then we paste it in. There we go. Then we go to the program execution history task. So there's different files in which Linux keeps its history. So for example, there's the .bash history file. There's the out.log file, which when a user tries to run a command as administrator using the sudo command. And there is history.log. So let's take a look at these files and see what is the first command in the root bash history file. Now, we are already the user root. See, if I type the command who am I, you'll see I'm user root, but we're in the wrong folder. You'll see we are in .ssh. Let's go one folder up, cd ... Then type pwd, and you'll see we're in the folder /root. And we can take a look at that bash history file. It's a hidden file. So if I do ls-al, you'll see we have this .bash _ history. We can take a look inside, cat bash _ history. And you'll see the first command the user run is nano etc passwords. So you can type that in. There we go. We completed this task. Now you might want to look at the history command if you want. If you type history, you can find the same thing. So the first command was nano etc history. And they didn't run this with the sudo command. They didn't run this as administrator, so it's not gonna appear in this out.log file. Okay, let's go to the third machine. Okay, once the machine has started, you'll see a new address here that you can connect to. You can say SSH, thread at whatever the address is now, copy it. Let's connect to that third Linux computer, because there seems to be a third one that has been infected. So let's copy the password, right click copy, and we'll paste it in. And you'll see we are now inside this third machine. Now, they say there's another way malware can keep access into a Linux computer. And you'll see this malware is doing some funny things. We see some output here that randomly appears. So another way is using services. So services can be found using the command systemctl. So if I go here and type it now systemctl, we'll get a list of different services. And you'll see the malware is doing funny outputs to the terminal. Now you can find many different services in here. So what we can do is only show the active services. We are not interested in which services are not active. So we can do -- type equals service, and --state is active. Notice that I started to type earlier. I typed systemctl space and then this command, but it is outputting all kind of things. So I'll try to press enter, and we get a list of all the active services. Now there's a lot of them. We could inspect them one by one to try and find if there's anything funny in there. So if we take a look here at all these services, you can see many different services, and in the meantime this malware is outputting all kind of gibberish to the terminal, which is quite annoying. So what we can do is take a look again, and you'll see there's different ones. This one says IP.manager or IPmanager.service. It's quite unique that they say here that .service. None of the others do that. We could take a look. I could say sudo. So we could check the status of that service. So we take systemctl status IP manager. So it might take a moment. So we see this service is running, and they run this funny script. You see this very long text. It doesn't look normal at all. Let's try to stop this service. So we say sudo systemctl service IP manager stop. And doesn't know that service. And let's take a look at it again, at the status. And let's take a look at the contents of this file. So right click, copy, cut, and then paste that file in. So you'll see these are all the commands. We found the malware. And you'll see they ask us about the flag, figure out what's going on. So we outputted the contents of the file, and we find the flag right here. So right click, copy, then we copy this, paste it in, and we now completed this room. We investigated 3 Linux servers, how they were infected, how they were hacked, and used various techniques to find out how.